Hello everyone. Today I am going to discuss the two problems of Leetcode Biweekly Contest 149, which is B and C. So the problems are reschedule meetings for maximum free time 1 and 2. So let's discuss the first problem. So the first problem is we are given an integer event time denoting a duration of the event when the event occurs from 0 to event time. Okay. Now we are also given to start time end time pairs and in non-overlapping meetings. Okay, so we are given the start time and end time of in non-overlapping meetings. Now we can reschedule at most k meetings by moving their start time while maintaining the same duration to maximize the longest continuous period of free time during the event. So let's take the first example only, you will understand it better. So this is the timeline. Okay, so the first event starting from 1 to 2 and the third event starting from 3 to 5. So k is 1, so we can shift any meeting left side or right side. Okay, so here you can see that we can move this meeting left side by 1 from 0 to 1. We'll get a space. Let me write it here. Okay, so this is our timeline: 0 1 2 3 4 5. So our first meeting is happening from 1 to 2 and the second meeting is happening from 3 to 5. So let's say 3 to 5. 3 to 5. Okay, so let's say we are shifting our meeting first meeting to the left side. So now our first meeting will happen from 0 to 1 and our second meeting will happen from 3 to 5. So here the maximum space is of length 2. Okay, so that's why 2 is our desired answer. Okay, you can see that our desired answer is 2. So we can reschedule at most k meetings. We can shift. So what does it mean? Reschedule means we can shift the meetings to the left side or to the right side. Okay, so how we are going to solve this? So for this problem, this problem is easy. We have to just have one some observation. Okay, so let's say some meetings are scheduled like this and this, and we can reschedule. What if we can reschedule all the meetings? What if we can reschedule all the meetings? So here you can see that what we can do. Let's say this is our timeline. So we can move all the meetings to one corner. We can move all the meetings to one corner. Then let's say the duration of the first meeting is d1, duration of the second meeting is d2, like that. So if we can shift all the meetings, then our desired answer will be total event time is from 0 to event time. So let's call that e. So total event time, let's say, is e, and e minus summation of di will be our desired answer. We will shift all the meetings to the left at most left and or at most right. Okay, so our desired answer will be e minus summation of di, but here we can move only k meetings. That is the catch. Okay, so how we are going to solve this problem? So uh, hmm, so let's say here instead of shifting all the meetings, we can shift only two meetings. Okay, we can only shift two meetings, so d1, d2, d3, d4 and d5. So we'll let's say we can only shift two meetings, right? So let's say we I am shifting the first meeting and I am shifting the fourth meeting. Okay, will that help us? Because shifting the first meeting is increasing the interval between 1 and 2, or we can say 0 and 1. So increasing d1 is shifting increasing modifying the first interval or the second interval, while increasing shifting the fourth meeting is modifying this interval or this interval. So that does not help. So we can shift 1 and 2. So that's the first observation here. The first observation here is that we'll only move k consecutive meetings. We'll move only k consecutive meetings. Okay, so that is one catch. Now let's say we'll try to move each and every k consecutive meetings. Where will we move? Okay, so let's say we are only moving the first two meetings. So we can move the first two meetings at most left, or we can move the first two meetings at most right. Okay, and here another important part here is that the relative ordering of the meetings is should be same. The relative ordering of the meetings should be same. So we can't pick d2 and put between d3 and d4. That is another important part for this specific problem. Okay, so that's why we can move d1 and d2 at to the left side or to the right side. That is our desired answer. Okay, so how we are going to solve this problem, I will explain through my code. Okay, so this is the code. So let's say we are maintaining the summation of di's for the last k meetings. So we are maintaining the summation of di's for the last k meetings. Now the interval, the start time and end time of 0, start time and end time will cover. Now our answer will be end time minus start time. Instead of e minus summation of dy, our answer will be end time minus start time minus summation of dy. So I hope you get it. Now important part is that how we are getting the summation of di and how we are getting end time and start time. So in time, a start time is nothing but e of I minus k. Okay, so let's say I am at this box, right? I am at this box. So I minus k will be d2. So in time of d2 will be our this left part, start time. So in time of d2 will be our start time. And what will be the end time? In time will be start time of I plus 1. End time will be start time of I plus 1. Okay, and there are other cases when our I minus k is 0, then we have to consider start time as 0, and when I plus 1 is equals to n, we have to consider end time as even time. Okay, so we have got start time and end time. Now we'll take what we can say, we can take a window sum. So I hope you know how to calculate window sum. So we'll take one variable c and we'll add the duration of meeting with the value of c. Now if I greater than equals to k, we have to let's say this is our window, and we have 1 2 3 4. So we have when we are shifting the window, we have to delete the value of this one. Okay, so that's why we are deleting the value of the duration of I minus k 1. Okay, so c minus equals to duration of the last one. Okay, so our answer will be maximum of answer comma end time minus start time minus c is the nothing but summation of di. Okay, I hope you get the solution. So what is the time complexity? The time complexity is nothing but order of n. Okay, that's the basic approach. So I hope you get the explanation of this part, this problem, reschedule meetings for maximum free time 1. I'll provide the link of the code for the first part in the description box. If you have any doubt regarding the first part, you can ask in the comment section. Now I will jump to the second part. I am not making separate videos for two parts because they are interdependent. The like the problem statement is very similar. Okay, so what is the second part? Second part means second part says that we can only move one meeting, we can only reschedule one meeting. But here I have explained that we can't really take d2 and put between d4 and d5. That's what we can do in this portion, because the here it is mentioned that the relative order of the meeting should stay same, but here that is not mentioned. In this version it is valid for the relative ordering of the meetings to be changed. Okay, so we can take d2 and put between d4 and d5. Okay, now how we are going to solve this? Now our k is 1 for this problem because we can only change one meeting. So how to solve this problem? Okay, now okay, now this the solution for this problem, how I have done this problem is completely different from the previous problem. Okay, so how I have solved this problem, I will explain to you. Let's say I have some meeting schedule like this. Okay, meeting schedule like this. Now I will maintain all the gaps. Okay, so this will be gap 1, this will be gap 1, this will be gap 2, this will be gap 3, this will be gap 4, and this will be gap 5. Okay, I hope you get it. Now let's say we are trying to reschedule this meeting. We are trying to reschedule this meeting. Let's say this is d1, this is d2, this is d3, and this is d5. Okay, let's say we are trying to reschedule this meeting. Now let's say we are putting this d2 in gap 2 or gap 3. We are putting this d2 in gap 2 or gap 3. Putting a meeting in a gap means that we are putting it into the left side of the gap or the right side of the gap. So we are putting a meeting in the gap 2 means that we are putting this d2 at the start of the gap 2. Okay, then we are merging the gap 2 and gap 3. Okay, that is one part. So if we put some meeting in its left gap or right gap, what is the value? So let's say we are putting the d2 meeting in the left gap g2 or right gap g3. So then our answer will be g2 plus g3 minus d2, because uh, that will be the maximum consecutive value. Let's say we have put d2 here, then this value will be g2 plus g3 minus d2. I hope you get it. Now let's say we are putting d2 in any other gap. Let's say we are putting d2 in g1 or g4 or g5, then this entire gap g2 and g3 will be merged. Okay, the entire gap g2 and g3 will be merged. Okay, I hope you get it. So this is not really exactly g2 plus g3 minus d2. This will be g2 plus g3, and if we are changing this d2, putting this g2 to any other graph, then the value will be g2 plus g3 plus d2. Okay, g2 plus g3 plus d2. So I have made the mistake earlier. If we change move this d2 to any other gap, the sum will be g2 plus g3 plus d2. I hope you get it. So that's how our approach is. I will now move to the code and I will explain how I am calculating g2, g3 and d2. Okay, so what I am doing, I am maintaining one gaps array, and the gaps array will be sorted. Okay, gaps array will be sorted. So d is ndi minus si. Okay, duration is ndi minus si. Now why d is not important here? I'm not sure why I have taken d here. That is completely irrelevant here. So gap is start time of the next meeting and end time of the current meeting. That is the gap. So we are putting gap in the gaps array. Now the first gap will be from 0 to start time of the first meeting. So we are adding is 0 to the gaps, and the last gap will be the difference between in event time and the end time of the last meeting. Okay, so t minus e of n minus 1. Here you can see that this start time end time events are sorted. Okay, so we are sorting the gaps array. Now the gaps that is g1, g2, g3 will be shuffled. We don't really care. I'll explain why we don't really care. Okay, so like the previous one, we are maintaining the start time and end time for the current event. Okay, we are maintaining the start time and end time for the current event. Here k is 1, that's why we are taking this. Okay, and duration is ndi minus si. Now let's say we are considering the this one, we are moving d2 to g2 or g3, then our answer will be end time minus start time minus d. I hope you get it. End time minus start time will be the entire thing, end time minus start time will be the entire thing, and we are deleting the duration. Okay, that's why et minus start t minus t. Now our L gap will be L2. Okay, L gap is si minus e2 et. This is our L2, and R gap is L3, which is end time minus ei. Okay, we are finding L gap and R gap. Now uh, uh, we will also be maintaining that L gap is less than R gap. Why I am doing this, I will explain. I am maintaining that this is L gap is less than R gap. Okay, now we are finding one gap which is greater than the current duration, because let's say we have some gap which is less than the current meeting. This, let's say our current meeting is this big and our gap is like this big, then we can't really put this meeting to some this gap, right? So we are finding the gap which is greater than the minimum gap which is greater than the current element. Okay, now if the current gap is equals to L gap, okay, if the current gap is equals to L gap, then we are incrementing the value of index. I hope you get it. Why? Let's say our gaps are like that. Our gaps are like 2 2 2 4 4. Okay, let's say 1 2 2 2 4 4, and our L gap, our this is 2, this is 2, and this is, let's say this is 4. Okay, let's say this is 4. Our g2 is 2, d2 is 2, and g3 is 4. Okay, so when I am taking the bisect left of 2, I'll be getting to this 2. Now this could be our g2, right? This could be our g2. That's why we are incrementing the value of index, okay, by 1. Now if again, if this is also equals to r gap, then we'll increment the value of index by 1 again, but this is not equals to r gap. Our r gap is 4. That's why we can put our event to this gap. We can put our event to this gap, okay. That's why if we found one gap, if index is less than length of gaps, that means we have found one gap. We are taking answer as maximum of et minus st. I have already explained that we are moving this d2 to this gap, so this will not remain. So our start time, end time minus start time, the entire thing will be the one candidate for maximum gaps, okay. I hope you get it. I will provide the link of this code also in the description box. So what is the overall time complexity? The overall time complexity is order of n log n, because we are doing some sorting also in the bicycle. This implements binary search, so the overall time complexity will be order of n log n. I hope you get the solution for the second part also. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you for watching.